There we go. That's the ticket. Okay, so what's the connection? What did you decide between the blue and the black? What are the connections between those two graphs?
Inverse.
Okay, now several people said reflections across the line y equals x. I'm glad you said.
All right.
Because that's the overall connection that I wanted. I wanted you to say they are inverses of each other. Okay. Now, one of the things that you guys need a lot of help with, and if you don't get this down, you won't survive this chapter. By the way, so next Tuesday's our retake, right? So Monday we'll be reviewing, Tuesday we'll be retaking. You got your choice of 1 through 4, 5 through 8. You probably need to get out of your folder, need to get that notes page that you've already done so you can add more to it. You get to use that notes page, right, on the retake. So make sure you are adding to it. Don't ignore me this weekend. Actually work on some math and add to that notes page so that you are better prepared for this test. We're going to do a 50-point test over 3-1 to 3-3. Hint, hint. Look, we're on 3-3. That means shortly after this, probably next Friday, we'll have the 3-1 to 3-3 test. Okay, because we'll be ready for that. And then we'll do another 50-point test over 3-4 and 3-5. And then you can retake one of those two. But just so you're aware, so next Tuesday's the retake, and then we will be ready by Friday to have another test coming your way. The one thing that I know that you guys forget a lot of is this. 2 to the third is equal to 8. That is called the exponential form. Okay? But there's another form of that same thing called the logarithmic form. And a lot of you forget how to write things in logarithmic form. So we probably need to go over that. All right, so we've got something called a base and an exponent, and it equals something called the argument. Base to the exponent equals argument. And so we need to, kind of remind ourselves. Now, I learned second period that so I want to ask you this question. Can you give me a one-word synonym for logarithm? Can you give me a one-word synonym? Remember, synonym means same. So a one-word synonym for logarithm.
E.
Don't start with E. One-word synonym. She at least guessed the first letter. Exponent, thank you very much. Now, you need to get it through your head that a logarithm is an exponent. Now, if you're going to ask me, well, why didn't they use EXP instead of LOG? Don't know. Okay? Right? Not ESP. That's a different thing. Okay, EXP. A logarithm is an exponent. You need to understand those two words mean the same thing. So when you go to the logarithmic form, guess where your exponent is? Right here. Logarithm means exponent. So if you're changing this 2 to the third equals 8 over into its log form, what exponent did you see there? 3. Okay, what's the base? Where does the base go in a logarithm? Isn't that the little subscript thing that gets written right there at a lower level? That only leaves you with one place to put the argument. So I'm hoping that you know it goes there. So log base 2 of 8 equals 3. That is the same exact statement as the one on the left, just written in a different form. What are we solved for? It is solved for the exponent. And then I'll answer your question. Solved. That is really important right there. It is solved for the exponent. That right there is going to come back when we try to solve equations where we don't know the exponent. Yes, what's your question? Ask. Come on.
So,
No, not the x root. No. That would be b to the 1x, b to the 1 over x. Okay, so we'll talk about that because that's exactly what I want to talk about that down there too. And I'll show you the difference. Okay, I'm glad you asked because that was where I was going next. Okay, so if we take this equation right here, it's got a y right there, it's got a base right here, and then it's got the argument right there. And we change it to its exponential form. Help me do that. Something to the something power equals something. What letter represents the base? Is it x, y, or b? It is b. What letter represents the exponent? It is y. Remember, logarithm means exponent. So your exponent was sitting right over here. That only leaves one thing left for the other side. What's that? X. Now, take a look at the equation for the blue graph. You said that was exponential growth. And take a look at this equation. What's the connection? No. Good try. They're inverses. What do you mean by that? The first thing we taught you about finding an inverse was switch x and y, wasn't it? There it is. Now, you would have never seen that. I mean, none of you are going to look at this and go, oh, yeah, x and y got switched. None of you are going to realize that here. But you do if you change it to its exponential form. You can easily see that the x's and y's got switched. Now, if x's and y's got switched, what happened to the domains and ranges? Switched. What's the domain of the blue one? What's this domain of the blue one? Domain, come on. Remember how we took everything and pushed it down on the x-axis? How much of the x-axis got covered? Negative infinity to? There's no vertical asymptote here, folks. It keeps going and going. Now, I realize it's increasing quickly, but it's going to keep going and going forever and ever this way. What's the range of the blue one? 0 to infinity. 0 with a bracket or with a parenthesis? Oh, good job, because you don't touch the asymptote. Nice. What's the asymptote of the blue one? Y equals 0. Thank you very much. When you switch to the log graph, what does the asymptote become? X equals 0. You can see the black graph here is getting closer and closer and closer and closer. Okay, so just look at the black graph only. Kind of block out the blue one on your mind. What's over here on the black graph? Over here, somewhere. Over here. Nothing. What's the domain of this function? Domain, that's the x's. 0 to infinity. So when I ask you what's over there, the answer is nothing. You might want to remember that for next week, but we'll come back to that. Okay. But that graph is telling me an answer to a question We need to practice evaluating logarithms without a calculator. Yes, 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 I know. You don't like it, but we're going to do it anyway. Now, in order to save your life, every time you see evaluating x, no calc, this is all no calc. If I give you an I-step calculator, it will make you feel comfortable a little bit, but it won't help you. Okay. So we can give you I-step calculator. It's not a big deal, but it's not really going to be of any use to you. But what you notice in every single one of these evaluate questions, whether you look at them homework, they don't ever do this. They don't ever put equals x. You better do this when you write. Okay? It will help you immensely if you do this. I do not know why textbooks do not typically do this. You're going to change this into its exponential form. So help me do that. Something to the something power equals something else. So, walk me through this. What's the base? 2. What's the exponent? X. What's it equal to? 8. So we filled in the 3 boxes with the 3 things that we saw in the log form. Now, it is your job, and every single one of these questions is going to require you to do algebra. Use your algebra skills to rewrite things as common powers. The common power here is going to be 2. So what would you rewrite 8? 8 is 2 to the what power? 3rd. Now before we answer this question, this might sound dumb, but if the left side is equal to the right side, how do I know that's true? Yeah. And the bases are exactly the same. What do we know about these exponents? They have to be the same. Yes, folks, it's that easy. X equals 3. Now, I know you guys struggled with logarithms last year. Okay, first time through, and it was overwhelming, I'm sure. Has been for generations. It will seem much easier this time because it's your second time through. Okay? All right? So now we need to do the next one. Something to the something power equals something. What's the base? 3. The exponent is x. And what does it equal? The square root of 3. Now, obviously 3 is the common base. The question is, what is the exponent on 3 which gets me the square root of 3? It is the 1/2 power. Yes, you have to remember that fractional exponents go with roots. Remember I drew that tree diagram, power over the root? And I'm not very good at drawing. So what do you think x is? 1/2, yep. If the left side equals the right side and the bases are the same, the exponents have to be the same also. Okay, next. Set it equal to x. Over and over and over again, I'm going to say that. Set it equal to x. Something to the something power equals something. Yeah, I know. Eventually, you don't have to draw boxes. It just kind of helps. It helps visualize this. And for those of you that struggle with logarithms, which there are many of you, I'm just trying my best to give you something so you know kind of a pattern to follow. What's the base? 5. What's the exponent? And what's it equal to? 1/25. Now, how do you rewrite 1/25 as a power of 5? It is going to involve a negative, yes. Negative what?
Oh, it's -2.
So is it -5 or -2? See, that 1 over 25 is the same thing as 1 over 5 squared. So it's got to be negative 2. Now, I understand in your minds, you're thinking 5 times 5. It's not the same thing as 5 to the 5th. 5 to the 5th is 3125. A little bit bigger than you wanted. So what's x? Negative 2. Don't feel bad if you need to stop me and ask questions, because happens frequently in the log section. Okay. Next. Be quiet. I know you're right. You're just ahead of them. Okay. What's the base? 4. What's the exponent? And it's equal to 1. How do you rewrite 1 as a power of 4? 4 to the 0, which means that x has to be 0. All right. Something to the something power equals something. What's the base? 7. Exponent? X equals 7. What's the answer? 1. Right? The exponent on 7, which gets me 7 to the first, is 1. You just need to keep in your brain that a logarithm is an exponent. So many kids forget that. Oops, that ain't it. All right, I'm going to add one here. Do I need to move it down? Yeah. How far? Okay. Now, I am going to take it up a notch. Okay. First, change it to its exponential form. Something to the something power equals something else. What do we have? 8 to the what? To the x equals the cube root of 16. Now, I have a master's degree in applied mathematics. I do not know how to write 16 as a power of 8. And if I can't do it, pretty sure you can't either. I know that 8 to the first power is 8. I know that 8 to the second power is 64. 16, we jumped right over that. So that must mean that it's between 1 and 2, and it's some really weird decimal. Nice try. I'm not going to be able to do that. So I have to have a backup plan. I have to be able to rewrite 8 and 16 to a common base. That common base will be smaller than either 8 or 16. Is there a number that you can think of that you could rewrite both 8 and 16, some common base that they share? A lot of people say 4. Now, 4 squared is 16. I got that one. But I don't know how to write 4 to a power and get you 8. 2 is correct. I had to go down lower. 2 is the common base between 8 and 16. So we're going to rewrite 8 as 2 to what power? 2 to the third, right? Yeah, try to resist the temptation to say 2 times 4. Okay? Because a lot of people say 2 to the fourth is 8. On the other side, we have the cube root. Is there any way to write 16 as a power of 4? I mean, as a power of 2. Sorry. 2 to the fourth. I think subliminally I was giving away the answer. Based on what you learned in Algebra 1, what are you allowed to do with these two exponents in the red box? What are you allowed to do with them? Power of a power. It's not addition. Addition comes in when we're multiplying like bases. That's when we add exponents. But when we have a power of a power, what do? We multiply them together. Now, on the other side here, how do you rewrite that? The cube root. The cube root. What exponent is the cube root? The what? The 1/3. That's true. You need to know that the cube root can be written as the 1/3 exponent. What are you allowed to do with these things circled, these exponents circled in the purple? What? Multiply. What do you get when you multiply 4 times 1/3? 4/3. That's true. 4 on the top, 3 on the bottom. For those of you who don't believe me, that's 4 over 1 times 1 over 3. Okay. Figure out what the answer is. You should be doing homework. 23 hours. Okay. Now that's a complex fraction which is equal to the correct answer. I would not want to see it that way, but you are at least headed in a better direction than a lot of people in this room who are just staring at the screen, not doing anything. If the left side is equal to the right side, and the bases are exactly the same, what do you know about these exponents? They're equal, right? Did you write that down? I mean, if you know they're equal, then set them equal to each other. Right? Those exponents have to be identical, right? If the left side and the right side are equal, then those exponents have to be the same. Okay, what do we do to solve it? Okay, when you say divide by 3, be careful. That's true. I'm not going to argue with you there. Back in middle school, we said multiply by the reciprocal. Thank you. So instead of dividing by 3, we would multiply by 1/3. It's probably best that you see it like this, because division by 3, I saw some I've seen some complex fractions, 4/3 over 3. I don't want to see it like that. What's the correct answer? 4 over something, what? 4 over 9, that is your correct answer to this question. And folks, remember we were trying to evaluate a logarithm. And no, we did not need a calculator. We needed to change it to its exponential form. We needed to see that we had to come up with a common base. So we rewrote each side to a common base and used our algebra skills to figure out what those exponents had to be, or what the x value was that would make those exponents the same. Yeah, we never threw a question like this at you in Algebra 2. You know, the most you got in Algebra 2 was something on the scale of like this. You know, I mean, now that's got similar qualities to the last one. But we never threw in the cube root on top of it. I mean, I was thinking about doing 1 over the cube root of 16. How would that have changed this if I had thrown 1 over the cube root of 16? Come on, what's the only difference if I had done that? 1 over the cube root of 16. Yeah, it would have made it negative 4/9. That's it. It would have thrown one extra piece in, which you need to be aware of. Okay. Those first two are duplicates, so I'm not going to do them. I don't know why they duplicated them. But this one's new. This one is in exponential form. You know, exponential form that says base to the exponent equals argument. Can you identify what the exponent is on letter C? This whole thing is the exponent? Yes. Now, there's nobody in the room that knows what that decimal is. Nobody knows what 6 to a power gives me 11. It's over 1, I know that, but that's about all I know. So, if I can't solve it in its exponential form, what form should I change it into? Let's do its log form. What's the base? 6, that's right. Nice. It's like there was an echo in the valley. What's a single word synonym for logarithm? Exponent. We know the exponent should be over here. What is the exponent? Thank you. Final answer. The tribe has spoken. Snuff. That'd be interesting if our math class ran that way, you know. You've been voted out of the tribe. Okay, log base 6 of 11 is your exponent, folks. That only leaves one other thing to be put in that other box. Yeah, the x. Now let me rewrite this so that it looks a little nicer. We have log base 6 of x on the left side, and we have log base 6 of 11 on the right side. Let me ask you a question. If the left side is equal to the right side, and the bases of the logarithms are the same, what do you know about the arguments? They have to be the same, don't they? What's x? 11. Nice job. Do you know how many people I've heard say that? The second time around, everybody learns more. It clicks. It starts, okay, now I'm getting this. You know. Second period thought I was a genius. I'm not, folks. They did so, you know that. It's only because you're seeing it again. That's really what's the big difference. Yeah, well, I know that's what people claim. And, you know, I may add to it and help you understand more, but set them equal to x. Solve these quickly. It shouldn't take you that long. By the way, when you have a common logarithm, these are referred to as common logs. What's the base? Hey, base 10. Okay, when you don't see the subscript, it's automatically 10. Now that is true if it says log. What if it said ln? What's the base? E, thank you very much. Okay, we'll talk more about that when we run into it next week. But you should solve all four of these pretty quickly. Yes, he's actually right. Watch. Yes. Yeah, except that usually you want to get your money. By the time I actually get back to my house,
Well, it doesn't say the subscript, though.
so you know it's a significant 132. It's a significant. You just don't want to rent one, you go for both usually. It's a hefty commitment. I enjoy it, but I didn't go this year. No. Yeah, they're fun. It's not so fun when, like, you know, this monster SUV's in front of you and they decide that they're going to park backwards and open the back end up, and suddenly it's like, well, I can't see part of the screen, you know. Yeah, that's annoying. Okay, so hopefully you said 10 to the x equals 100. Anybody know how to rewrite 100 as a power of 10? 10 to the what? 10 to the second. Now, I have seen people say 10 to the 10th. I don't know. I've seen 10 to the 10th several times today. X equals 2. So, 10 to the 10th equals 1,000. Ouch, ouch. Pull the dagger out now. Ow.
No, you're pushing it deeper.
So 1 with 10 zeros, okay? So, all right. 10 to the x equals the 5th root of 10. What did you do with what did you do with this? 10 to the what? Come on, what is this one? 1/5. You are correct. Okay. So 10 to the x equals 1 over 1,000. I think you meant 10 to the negative third. Yeah, you said negative 10 to the third. Okay. I knew what you meant. Okay, so what's x? We don't know what x is? Seriously? X is equal to negative 3.
Oh, wait. I thought you were
Say it again. Is log never required?
Not required. That's like base 10.
You do not have to have a base subscript when you automatically know it's base 10. Okay? Good question. No, that's fine. I want to make sure everybody understands this. Okay, so what'd you do with this one? It's already in exponential form, so we need to change it to what? Log form. Okay. So log base something of something equals something. Log, the base is 10. I would agree with you there. What's your exponent? Your exponent is log 6. That only leaves me with one thing, x. So log x equals log 6. Yep, folks, x is 6. If you can't change them between these two forms, it's over, folks. This chapter is going to be horrible. You need to be able to go back and forth between these two forms easily. So if you need to practice with me or go to the resource room or go online and find some places to practice, please do so. Watch videos, whatever you need to do to make sure you can do this well. Yes.
So why did they put 10 just like this?
Okay.
It's not really needed.
It's still there,
Oh.
right? It's the common log, so we know it's still there.
Okay.
That's like me saying to you, you know, okay, if I asked you, let's say I wrote the letter x, okay, and I asked you, what's the coefficient? That's the number in front. That's a 1. What's the exponent? The answer is 1.
So it's kind of
Okay, but I don't write them down. We just know that that's the assumption, just like on a square root. You know that the assumption is the index is a 2. We never write that,
okay.
but that's the assumption. We know that that's what a square root is.
Gotcha.
Keep asking those good questions. I like that.
Have you ever had a